In this video, we're going to take a look at our final method for solving quadratic equations, the quadratic formula. And this is the method that will work for any situation, regardless of the type of quadratic equation that you have. So you can always have it in your back pocket to use if your other methods aren't working. It's not always the quickest way to get to the answer, but it will always work. So here's our formula right here. This will be given to you on your formula sheet, but it's one that you should kind of familiarize yourself. And we use this under the assumption that our equation is in standard form. So we have our A coefficient, our B coefficient, our constant, and the equation must be set equal to 0. Make sure your terms are in order because that's what these letters here represent. The part of the quadratic equation that sits underneath the radical, our argument here, is called the discriminant. And the value of the discriminant lets us know about the number and type of roots our equation is going to have. If that discriminant is negative, that would mean that I would have to take the square root of a negative number to find my roots, and that's not going to happen. So we would have 0 real roots. If the discriminant is 0, then when I do plus or minus the square root of 0, it's going to be the same thing whether I do addition or subtraction. So we're just going to have 1 real root. If the discriminant is positive, then we would have 2 positive roots. So go ahead, pause the video, and see if you can determine the discriminant and the number of roots for each of the quadratics listed below. So for the first one, when we substitute in our values, we end up with a value of negative 220, and that means that we are going to have no real roots because I can't take the square root of that negative value. For the second one, we first have to move that 12 over to the left-hand side to make sure that we have an equation equal to 0. When we solve, we get a discriminant of 244. That's positive, so it means we have 2 real roots. So now we're going to use the quadratic formula. When we're given a quadratic equation, sometimes factoring won't work. Completing the square usually works, but sometimes it gets a little messy. Or graphing. This should say graphing. Because this is where we want to find what those roots were that sat in between the consecutive integers. So what we're going to do is we're going to substitute our values into the quadratic formula and see what we get. So here's our first example. The first step that you need to show is your substitution step. So we're going to substitute in our values. So we have negative b, so b here is negative 4. So we're going to have negative b. You want to make sure you're careful with your signs when you're substituting in. Plus or minus the square root of b squared minus 4 times a times c all over 2a, or 2 times 11. And now I'm just going to use the order of operations to go ahead and simplify. So negative 4 is positive 4, plus or minus the square root. Negative 4 squared is 16, minus 4 times 11 times 9 is going to be 396, all over 22. Now we can keep going. So we have 4 plus or minus the square root of negative 380 all over 22. And once I get to this point, I notice that my discriminant is negative. So that means we're actually not going to be able to go any further. So here, if we were writing it in roster form, we would write the empty set. We could also write no solution if we were just asked what the answer was. And that's because of our negative discriminant here. Alright, for this one, we first have to get 0 on the other side of the equal sign. So we're going to move that 8 over. So we have 2x squared minus 6x minus 8 equals 0. And now we're going to do the same thing. We're going to substitute in our values one at a time. We have a of 2, b is negative 6, and c is negative 8. So negative b is going to be negative 6, plus or minus the square root of b squared minus 4 times a times c, and that is all divided by 2a. So now once again we go through our order of operations. So that negative 6 becomes positive 6, plus or minus 6, or negative 6 squared is 36, minus 4 times 2 times negative 8, so we're going to have minus negative 64, or plus 64, all over 4. So now we can keep simplifying. So x equals 6 plus or minus the square root of 100 all over 4. We can reduce that square root. So we have 6 plus or minus 10 all over 4. And this is where we can split into 2 different scenarios to find our solutions. So you have 6 minus 10 over 4 and 6 plus 10 over 4. And of course we want to simplify this. So 6 minus 10 is negative 4. Divided by 4 is going to be negative 1. And 6 plus 10 is 16. Divided by 4 is positive 4. So our two solutions here are negative 1 and 4. Go ahead and pause the video and try the last example on your own. Alright, for this one, we again start by moving that 5 over so we have a 0 on the other side of our equal sign. Then we substitute all our values in, and we get negative 10 plus or minus the square root of 100 plus 60. So inside the radical we're going to get 160, which we can reduce to 4 root 10. We also have negative 10 in the numerator and a 6 in the denominator. These three numbers are divisible by 2, and since all three of them have that common factor, I'm allowed to take that out and reduce. And we end up with negative 5 plus or minus 2 root 10 over 3. And that would be our final answer. If you want to, you can write it separately. You could have negative 5 plus, or not negative 5 plus or minus. We could have negative 5 plus 2 root 10 over 3, and negative 5 minus 2 root 10 over 3. But usually we're going to just write it succinctly, one term with the plus or minus in the middle there. So again, this will work for all quadratics. It's not always the best method to use because it is a little more involved, and sometimes the other methods can be a little faster, but it will always work to solve a quadratic equation.